Let's take a quick look at the distance and midpoint formulas, which I've got typed here for you. Personally, I don't use this formula here. Instead, I like to use the Pythagorean Theorem, as you'll see me illustrate for you. Basically, for this midpoint formula, you're going to find the average or the mean of the x's, and then you're going to do the same thing. You're going to find the average or the mean of the y values. And that is the quick and easy way to come up with the midpoint. Now let me show you where the distance formula comes from. Let me draw a picture here for you, and it will be of the first quadrant. And as you well know, the x and y axis are at right angles to each other. And let's just say we have two arbitrary points within this quadrant that we want to find the distance between. So I will label that as D. And let's say that this first point is located at x1, y1, and that the second point is located at x2, y2. I guess I can draw those dotted lines in. Okay, what can we do? Well, we can pretend there is a right triangle here, because this is all based upon the Cartesian coordinate system, which has right angles. And what is the length of this side here? Well, it's going to be x2 minus x1. For example, let's say this went from 3 till 10. Wouldn't that be 7 units wide, which is found by going 10 minus 3? Likewise, the height of that triangle is going to be y2 minus y1. Now, if we take a look at the Pythagorean theorem, the distance squared is going to equal a squared plus b squared. And notice how I'm using d instead of c for the hypotenuse. I can then square root each side and have d equals the square root of, and what is my a getting squared? It's the x2 minus x1 getting squared, and then the b squared can be substituted out with y2 minus y1 squared. And so basically, as you can see here, the distance formula is based upon the Pythagorean theorem. Now let's apply this to a problem. We want to find the distance and the midpoint between these two. Now let's start with the midpoint. Now to find the midpoint, I need to find the halfway point, at least on the x's, between -3 and 7. Now you can either just do that in your head, or you can say, take the -3 and the 7, add them up, and divide by 2. And then for the y-coordinate, do the same thing for 5 and 2. Add the 5 and 2 together, and then divide by 2. You will then find out that the midpoint between these 2 points is at 2, 7/2, or 3.5. Now let's find the distance between these same 2 points, -3, 5, and 7, 2. Now for this first problem, I'm going to actually draw a quick sketch of what's going on here. -3, 5 is 3 units to the left and 5 units up, and 7, 2 is going to be 7 units to the right and 2 units over. So basically, I need to find the distance or length of that line segment that I've just drawn in there. Now, I'm going on the x, let me pretend there's a triangle here. I'm going from a height of 2 to a height of 5. Doesn't that mean that the length of that side of the triangle would be 3? And if on the x-axis I'm extending from -3 to 7, doesn't that mean that the base of this triangle is 10 and that this is a right triangle? I can use Pythagorean theorem to say 3 squared plus 10 squared is going to equal d squared, or 9 plus 100 is d squared, and that d is equal to the square root of 109. Now personally, I don't always go through and draw out this triangle. For me, it's enough just to say, hey, look at these x's. Those are 10 apart. Hey, look at these y's. Those are 3 apart. 10 and 3 each are my legs. Square the lengths and add them together, and boom, I can use the Pythagorean theorem without having to draw those triangles. Let's do this again, but let's have a fraction involved. For the midpoint, I want to average the x's. That's the 4 and the -5. So 4 plus a -5 divided by 2. And then for the y's, 5/2, I want to add that to the -1, so plus a -1 divided by 2. When I do that, I get negative 1 over 2, and this becomes 3 halves divided by 2, which is 3/4. So there's our midpoint. As far as the distance is concerned, I can use the distance formula, or I can draw a quick picture. That is really the quick way for me to do this well, because I don't want you to have to memorize a formula. I'd rather you have kind of a visual way to handle it. So there's my -5, -1, and 4, 5 halves is going to be right about there. So let's take a look at what's happening. Along the x-axis, I'm going from -5 up to 4. That means that this side is going to be 9 units long. On the y-axis, I'm going from a height of -1 up to a height of 5 halves, or 2.5, and so that the length of that side will be 3.5. So let's take a look at this with the Pythagorean theorem. I'm going to have 9 squared plus 3.5, or 7 halves squared, is equal to d squared. That becomes 81 plus 49 over 4 is d squared. And basically, what do I have? I've got 81. Well, let's put this over a common denominator of 4. Let's make that 324 over 4 plus 49 over 4 is d squared. And then I can add the numerators together. That is going to give me 373 over 4 is equal to d squared. And then square rooting each side, d will equal, and I can ignore the plus or minus sign because I know we're dealing with distance here, the square root of 373 divided by 2.